Hello, so today we're going to be talking about Module 17.4, characteristics of a quadratic function. Remember, to be a quadratic function, your a cannot be a 0. So what we're talking about is your y equals ax squared plus bx plus c, and your a cannot be 0. So it has to have something squared. So what we're going to have to do is take this first equation, the y equals negative 2x plus 20. So it's got a bx here, it's got a c, but it does not have an a, so your a is 0, so it is not a quadratic function. Now for letter b, you have to rewrite this one. So we're going to subtract 3x squared from both sides. So it's going to be y equals negative 3x squared minus 4. So there's no x there, so you can say that your b is 0. So plus 0x minus 4. So your a is negative 3, your b is 0, and your c is negative 4. So that is a quadratic equation. So same thing with letter C. All you're going to have to do is put it into the y equals ax squared plus bx plus c. So easiest way to do that is to add y to both sides and then subtract 4x. So you would get, and then rewrite it. So 4x squared minus 4x plus 2 equals y. So your a is going to be 4, your b is negative 4, and your c is a positive 2. So we got that by, we added y to both sides, and then we subtracted 4x, which you guys have been doing that for a while. Okay, so if you take a look here, the biggest thing that tells you is if your x is squared. So if you look at number 7, your x is not squared, so it's not quadratic. Same thing with number 8. It's you have 1 half x minus 4. That's actually going to be a linear equation, so not quadratic. So number 5, yes, that is quadratic because it could be written in the y equals ax squared plus bx plus c. Same thing with your number 6. And number 7 and 8 are not quadratic because your a is 0. Because they don't have an x squared, so you can assume your a is 0, which makes it not quadratic, and in this case, these are linear. So now we're going to talk about minimum and maximum values. So you already know that a parabola opens up if your a is positive, so that would be a positive. Then it opens down if a is negative. So these are going to have a minimum and or a maximum. So if it's positive, you're going to have a minimum. So it can never be smaller than this number, than wherever your vertex is. So if you look at this example, the y equals x squared plus 6x plus 9. So your a is positive, so it's going to open up. Your vertex is at negative 3, 0, and your y value is going to tell you what your minimum is. So your minimum here is 0. So your y can never be lower than 0, but it would go up to infinity. Now, if your if your a is a negative, it's going to open down, which is going to give you a maximum. So it's never going to be higher than that at your vertex. So here your vertex is at 3, 5, so your maximum is at 5. So if you look at example 2, right here it says determine the maximum or minimum of each quadratic function from the graph. So right here you can say that it has a maximum at 1, 2, 3, 4, 5. So this one has a maximum of 5. Letter B, it has a minimum of negative 5. So when it's down, that's the minimum. That's your minimum down there. So for letter C, you have to look at your vertex. Remember, it's at HK. So it's going to be -1, -6. So find your vertex, -1, -6, and your minimum is your y value. So it's going to be -6. You know it's a minimum because that 2 is telling you it opens upward. Now for letter D, it's a -3, so it's going to open going down. So you're going to have a maximum. Your maximum is 5. So for 10, 11, and 12, if you're doing these, you can pause video. 10 should have a minimum -1. Number 11, since it's negative, it opens like this. Draw a picture. It could help you. It's got a maximum at 8. And then number 12 opens down, so it's got a minimum of 3. Okay, so now we have the zeros of a function. So the zeros of a function is a value of x that makes the value of the function 0. The zeros of a function are the x-intercepts of the graph. So all you have to do is just look at the graph, and wherever it crosses the x, those are your zeros. So we have right here, we have a 2 and a -1. And what you can do is you can plug those into your equation to double check. So if you plugged in a -1, you'd get 0. Plugged in a 2, you get 0. Same thing, sometimes they have only one 0. Remember, you can have 0, no solution. You can have one solution or 2 solutions. So for letter B, there's one solution, and your 0 is 1. For C, it does not cross the x, so there's no solutions, no zeros. Oh, sweet, I put that on there twice. Okay, so like as you can see, number 14, there's no solutions. It does not cross the x. And then for number 15, you have 3. And then we have one more thing that we're going to talk about, and that is the axis of symmetry. So the vertical line that divides a parabola into 2 symmetrical halves is called its axis of symmetry. The axis of symmetry passes through the vertex of the parabola. You can use the zeros of a function to find the equation of the axis of symmetry. So if you have 1, 0, the axis of symmetry is going to be your x value there. So if your vertex is at 3, 0, your x value, 3, is your axis of symmetry. If you have 2 zeros, so here we have -4 and we have 0. So what we have to do is just add those both up, divide by 2. So -4 plus 0 divided by 2 is -2. So your axis of symmetry is -2. That's where your vertex is going to be. So we can do an example really quick here. For A, it only has one solution at 2, 0. Your x value is 2, so your axis of symmetry is 2. Now for letter B, it crosses twice. It crosses at 1 and 5. So you're going to do 1 plus 5 divided by 2, which is 6 divided by 2 equals 3. So your axis of symmetry is x equals 3. If you want to draw the dashed line, that's fine. So just like number 16, it only crosses once, and your vertex is at -3, 0. So your axis of symmetry is at -3. For number 17, look at where the x crosses. So we have a -2 plus 4 divided by 2, which is 2 divided by 2, which equals 1. So your axis of symmetry is at 1. So let me know if you have any questions on this. Shouldn't be too difficult, but if you need some help walking through any of the problems, let me know. Thanks. Have a great day.